Find the trigonometric ratios for angle A. Here's angle A right here. And this is a 45, 45, 90 right triangle. Now remember, this is a special triangle in that this hypotenuse is radical 2 times one of the shorter sides. So let's say I let x equal CA here. So it would be radical 2 times x equals 12. And there are a couple different ways to solve this. You can divide by radical 2, which is fine, and you get 12 divided by radical 2, and then you would simplify further. But I'm going to show you a different strategy. I'm going to multiply both sides by radical 2. So it'll be radical 2 times x equals radical 2 times 12. Now radical 2 times radical 2 is radical 4. And radical 4, or square root 4, is 2. So this is simply 2 here. The square root 2 times square root 2 makes 2. Then you have this x here that is multiplied by, so 2x equals. And then this is square root of 2 times 12. And really, when you write it, you're supposed to put the 12 first. So it's 12 square root 2. I'm just using the commutative property of multiplication. To solve for x, divide both sides by 2. And you get x equals 12 square root 2 divided by 2. The 12 and the 2 are reduced to a 6. So x equals 6 square root 2. Now the other way to do this, what if you divide by radical 2 or square root 2 up here in the first step? It would be x equals 12 divided by square root 2, which is really the answer, but in math, good form requires no radicals in the denominator. So you're going to multiply by square root 2 over square root 2, and that creates x equals 12 square root 2 over square root 4, which is the same thing as 12 square root 2 divided by 2, and the 12 and the 2 reduced to a 6, and you get x equals 6 square root 2. Okay, so those are two different ways to find this side x. So this is 6 square root 2, and this is 6 square root 2. Okay, now we want to find the trigonometric ratios for angle A. So the sine of angle A is the opposite side divided by the hypotenuse. So it's 6 square root 2 divided by 12. And you can reduce the 6 and the 12. That makes a 2 in the denominator. So it's going to be square root 2 divided by 2. Now cosine of angle A is going to be the adjacent side divided by the hypotenuse. Well, the adjacent and opposite sides are congruent here for 45, 45, 90. So cosine of A is going to be the same thing. It's going to be 6 square root 2 divided by 12, or just square root 2 over 2. So sine of A, cosine of A, those have the same values. And that's only true when you have a 45, 45, 90, or an isosceles right triangle. Now the tangent of A is the opposite side divided by the adjacent side, so it's going to be 6 square root 2 divided by 6 square root 2. And the square root 2's and the 6's simplify out to get 1. So the tangent of A, or the tangent of 45 degrees, is 1. So I'll put sine of A is square root of 2 over 2. Cosine of A is square root of 2 over 2. And tangent A is simply 1. These are the trig ratios for angle A in a 45, 45, 90. And these ratios actually apply to any 45, 45, 90 or isosceles right triangle, because those triangles are all similar to this one.